Welcome to Microsoft Azure Administration, a comprehensive course designed to equip you with the skills and knowledge needed to manage and optimize Azure environments effectively. In today's rapidly evolving digital landscape, cloud computing has become a cornerstone of modern IT infrastructure, and Microsoft Azure stands at the forefront of this transformation. Throughout this course, we'll delve into the core aspects of Azure administration, providing you with hands-on experience and practical insights. You'll learn how to manage Azure subscriptions and resources, allowing you to control costs and optimize resource allocation efficiently. We'll explore the intricacies of implementing and managing storage solutions, ensuring your data is secure, accessible, and scalable within the Azure ecosystem. Virtual machines form a crucial part of any cloud infrastructure, and you'll gain proficiency in deploying and managing these critical components in Azure. We'll also cover the configuration and management of Azure Virtual Networks, enabling you to create robust, secure networking environments for your applications and services. Identity management is a cornerstone of security in the cloud, and we'll dive deep into managing identities using Azure Active Directory. You'll learn how to implement robust authentication and authorization mechanisms, safeguarding your Azure resources from unauthorized access. As a Microsoft Azure administrator, you'll play a pivotal role in your organization's cloud strategy. You'll be responsible for implementing, monitoring, and maintaining Microsoft Azure solutions, including major services related to compute, storage, network, and security. This course will empower you to make recommendations on services used for optimal performance and scale, as well as provision, size, monitor, and adjust resources as appropriate. By the end of this Microsoft Azure Administration course, you'll have a solid foundation in Azure administration, empowering you to tackle real-world challenges and drive your organization's cloud initiatives forward. You'll be well prepared to design, implement, and manage Azure solutions that meet the unique needs of your business. Let's embark on this exciting journey into the world of Microsoft Azure administration, where you'll gain the skills to become a proficient Azure administrator and a valuable asset to any organization leveraging Azure cloud services. Let's take a moment to understand who this course is designed for. Azure Administration Essentials targets IT professionals who are stepping into the role of Azure administrators or looking to enhance their existing skills in this domain. As an Azure administrator, you'll be at the forefront of cloud management, taking on crucial responsibilities in implementing, managing, and monitoring cloud services. Your role extends beyond mere maintenance. You'll be actively involved in provisioning resources, determining appropriate sizes for various services, and making real-time adjustments to ensure optimal performance and cost efficiency. To excel in this role, a solid foundation in key IT concepts is essential. You should have a good grasp of virtualization technologies, as these form the backbone of many cloud services. Familiarity with networking principles is crucial, as you'll be dealing with complex network configurations in the cloud environment. A strong understanding of identity management will be vital for securing your Azure resources effectively. Lastly, knowledge of storage solutions is important, as data management is a critical aspect of any cloud administration role. While prior experience with Azure is beneficial, it's not a strict prerequisite. However, you should be comfortable with general IT concepts and have some hands-on experience in managing IT infrastructure. This course will build upon your existing knowledge, introducing Azure-specific concepts and tools that will empower you to manage cloud environments effectively. Remember, the cloud landscape is ever-evolving, and as an Azure administrator, you'll be at the forefront of this technological revolution. Your willingness to learn, adapt, and continuously update your skills will be key to your success in this dynamic field. Are you ready to embark on this exciting journey into Azure administration? Let's dive in and explore the powerful world of cloud computing with Microsoft Azure. Over the coming sessions, we'll embark on a comprehensive journey through the key aspects of Azure administration. Let's take a moment to explore the exciting topics that lie ahead. We'll kick off by diving into Azure subscriptions, the foundation of your Azure experience. You'll learn how to effectively manage these subscriptions, ensuring optimal resource allocation and cost control. From there, we'll transition into the critical realm of identity management, where you'll master the art of securing your Azure environment and controlling access to your valuable resources. Infrastructure administration forms the backbone of any cloud solution, and will equip you with the skills to confidently manage Azure's robust infrastructure services. This naturally leads us into the world of virtual networking, where you'll learn to design and implement scalable, secure network architectures in the cloud. Bridging the gap between your on-premises environment and Azure is crucial for many organizations. We'll explore various connectivity options, enabling you to create seamless hybrid cloud solutions. Hand in hand with this, you'll learn the intricacies of network traffic management, optimizing performance and security across your Azure deployments. Storage is a fundamental component of any IT infrastructure, and Azure offers a wealth of storage solutions. We'll guide you through these options, helping you choose and implement the right storage strategies for your specific needs. Building on this foundation, we'll delve into virtual machines, teaching you how to create, scale, and manage these versatile compute resources effectively. In today's fast-paced development world, web apps and containers play a crucial role. You'll gain hands-on experience in deploying and managing these modern application platforms within Azure. Of course, protecting your valuable data is paramount, so we'll cover comprehensive data protection strategies, including backup and disaster recovery solutions. Finally, we'll round off the course by exploring Azure's powerful monitoring and optimization tools. You'll learn how to gain deep insights into your Azure resources, enabling you to fine-tune performance and maximize the value of your cloud investments. Each of these topics builds upon the last, creating a comprehensive skill set that will empower you to confidently manage and optimize Azure environments. Remember, Azure is an ever-evolving platform, and this course will not only teach you the current best practices, but also equip you with the foundational knowledge to adapt to future developments. Are you excited to dive into these topics and become an Azure administration expert? Let's get started on this transformative learning journey. Before we dive into the intricacies of Azure administration, it's important to outline the foundational knowledge that will help you make the most of this course. While Azure offers powerful tools and services, having a solid understanding of core IT concepts will significantly enhance your learning experience and ability to apply Azure solutions effectively. First and foremost, familiarity with on-premises virtualization technologies is crucial. This includes knowledge of virtual machines, virtual networking, and virtual hard disks. Understanding how these components work in a traditional data center environment will provide you with valuable context as we explore their cloud-based counterparts in Azure. Network configurations form another vital prerequisite. You should be comfortable with key networking concepts such as TCP/IP, domain name system, DNS, and virtual private networks, VPNs. Additionally, a basic understanding of firewalls and encryption technologies will be beneficial as we delve into securing your Azure environment. Active Directory concepts play a significant role in Azure identity and access management. Prior experience with users, groups, and role-based access control in an on-premises Active Directory environment will give you a head start when we explore Azure Active Directory and its advanced features. Lastly, an understanding of resilience and disaster recovery principles is essential. Familiarity with backup and restore operations will provide a solid foundation as we explore Azure's robust business continuity and disaster recovery solutions. Don't worry if you're not an expert in all these areas. The course is designed to build upon these concepts, providing Azure-specific context and practical applications. If you find any of these topics challenging, consider reviewing them briefly before we proceed. Remember, Azure administration is a journey, and this course is your guide to navigating the exciting world of cloud computing with confidence. Are you ready to leverage your existing knowledge and expand your skills in Azure administration? Let's embark on this learning adventure together. Welcome to our exploration of Microsoft Azure fundamentals. As we embark on this journey, it's crucial to understand the significance of Azure in the modern technological landscape. Microsoft Azure stands at the forefront of cloud computing, offering a robust and versatile platform that caters to a wide spectrum of business needs. At its core, Azure is a cloud computing platform that provides an ever-expanding set of services. These services are designed to empower businesses, regardless of their size or industry, to build solutions that align with their unique goals and objectives. The beauty of Azure lies in its flexibility and scalability, accommodating everything from simple web services to complex, fully virtualized computing environments. For businesses looking to establish their digital presence, Azure offers straightforward web hosting services. This allows companies to quickly and efficiently create and maintain their online platforms without the need for extensive infrastructure investment. However, Azure's capabilities extend far beyond basic web hosting. One of Azure's key strengths is its support for running fully virtualized computers. This feature enables businesses to manage custom software solutions in a cloud environment, providing the flexibility and scalability that modern enterprises require. Whether you're running specialized applications or need a robust testing environment, Azure's virtualization capabilities have you covered. Azure also excels in providing a wealth of cloud-based services that form the backbone of many modern IT infrastructures. These include remote storage solutions, which allow businesses to securely store and access their data from anywhere in the world. Database hosting services in Azure provide robust, scalable, and highly available database solutions, crucial for data-driven businesses. Centralized account management is another cornerstone of Azure's offerings. This feature simplifies the complex task of managing user identities and access across various applications and services, enhancing both security and efficiency. Perhaps most excitingly, Azure is at the cutting edge of emerging technologies. The platform offers services focused on artificial intelligence, AI, and the Internet of Things, IoT. These advanced capabilities open up new possibilities for businesses to innovate, automate processes, and gain insights from their data like never before. As we delve deeper into Azure fundamentals, we'll explore these services in greater detail, providing you with a comprehensive understanding of how Azure can transform your approach to cloud computing and drive your business forward in the digital age. Azure Fundamentals serves as your comprehensive introduction to the world of Microsoft Azure and its myriad services and features. This carefully curated series is designed to provide you with a solid foundation in cloud computing, specifically tailored to Azure's ecosystem. At its core, Azure Fundamentals is structured as a series of 3 interconnected learning paths. Each path is crafted to build upon the knowledge gained in the previous one, ensuring a logical and progressive learning experience. This structure allows you to gradually develop your understanding of Azure, from basic concepts to more advanced topics. The first learning path typically introduces you to the fundamental concepts of cloud computing and how Azure fits into this landscape. Here, you'll explore the basic principles that underpin cloud services and begin to understand how Azure can benefit businesses of all sizes. Moving forward, the second path often delves deeper into Azure's core services. This is where you'll start to get hands-on with Azure's compute, networking, and storage solutions. You'll learn how these services work together to create robust and scalable cloud solutions. The final path usually focuses on Azure's governance and management features. This crucial section helps you understand how to maintain control over your Azure resources, manage costs, and ensure compliance with various regulatory standards. One of the key strengths of Azure Fundamentals is its emphasis on practical, hands-on learning. Throughout the series, you'll encounter interactive exercises that allow you to apply your newly acquired knowledge in a real Azure environment. These exercises use a temporary Azure portal environment called the Sandbox, which provides a risk-free space for you to experiment with Azure services at your own pace. It's important to note that Azure Fundamentals is designed to be accessible to a wide range of learners. While having some general IT knowledge can be beneficial, it's not a strict requirement. The series is structured to accommodate both those new to cloud computing and those with some prior experience, making it an ideal starting point for anyone interested in Azure. As we progress through this presentation, we'll explore these aspects of Azure Fundamentals in more detail, providing you with a clear roadmap for your Azure learning journey. At its core, cloud computing represents a paradigm shift in how we deliver and consume computing services. Rather than relying on local servers or personal devices, cloud computing harnesses the power of the Internet to provide a wide array of IT resources and services. This approach offers unprecedented flexibility and scalability, transforming the way businesses and individuals interact with technology. In the realm of cloud computing, you'll find a diverse ecosystem of services. These range from the familiar building blocks of IT infrastructure, such as virtual machines, storage solutions, and databases, to more advanced offerings like Internet of Things, IoT platforms, machine learning algorithms, and artificial intelligence services. This comprehensive suite of tools empowers organizations to innovate and operate more efficiently than ever before. One of the most compelling aspects of cloud computing is its ability to transcend the limitations of physical infrastructure. Unlike traditional data centers, which require significant upfront investment and ongoing maintenance, cloud services can be provisioned and scaled rapidly. This agility is a game changer for businesses facing fluctuating demands or looking to expand their IT capabilities quickly. Imagine a scenario where your company experiences a sudden surge in website traffic or needs to roll out a new application globally. In the pre-cloud era, this might have necessitated weeks or months of planning, hardware procurement, and setup. With cloud computing, you can potentially address these needs within hours or even minutes, adjusting your resources to match your exact requirements. As we delve deeper into the world of cloud computing, we'll explore how these principles translate into practical benefits for organizations of all sizes. From startups to multinational corporations, the cloud is revolutionizing the way we approach IT infrastructure and application development. Are you ready to discover how cloud computing can transform your approach to technology? Let's continue our journey into this exciting and dynamic field. The shared responsibility model is a fundamental concept in cloud computing that delineates the division of responsibilities between the cloud provider and the consumer. To fully grasp this model, let's first consider a traditional on-premises data center scenario. In a conventional corporate data center, the company bears the full weight of responsibility. This encompasses maintaining the physical space, ensuring security, and managing or replacing servers as needed. The IT department is tasked with maintaining all infrastructure and software required to keep the data center operational. They're also typically responsible for system patching and version control. The shift to cloud computing introduces a new paradigm where these responsibilities are distributed between the cloud provider and the consumer. This distribution varies based on the cloud service type being utilized, whether it's infrastructure as a service, IaaS, platform as a service, PaaS, or software as a service, SaaS. In the cloud model, physical security, power supply, cooling systems, and network connectivity fall under the purview of the cloud provider. This allocation makes sense as the consumer isn't physically collocated with the data center and thus can't reasonably manage these aspects. On the flip side, the consumer retains responsibility for the data and information stored in the cloud. This includes ensuring the confidentiality and integrity of the data. Additionally, the consumer is accountable for access security, which involves granting appropriate permissions to users who require them. It's important to note that some responsibilities can shift depending on the specific scenario. For instance, if you're utilizing a cloud SQL database service, the cloud provider would be responsible for maintaining the actual database. However, you, as the consumer, would still be responsible for the data ingested into the database. Conversely, if you deployed a virtual machine and installed an SQL database on it, you would be responsible for database patches and updates, as well as maintaining the data and information stored within. The shared responsibility model is closely tied to the cloud service types, IaaS, PaaS, and SaaS. These service types represent a spectrum of responsibility distribution between the consumer and the provider. IaaS places the most responsibility on the consumer. In this model, the cloud provider is primarily responsible for the basics: physical security, power, and connectivity. The consumer, however, manages everything else, including the operating system, storage, and deployed applications. At the other end of the spectrum, SaaS shifts most of the responsibility to the cloud provider. In a SaaS model, the provider manages the application, operating system, and underlying infrastructure. The consumer's main responsibilities are data management and user access. PaaS sits between IaaS and SaaS, offering a more balanced distribution of responsibilities. In a PaaS model, the provider manages the runtime, middleware, and operating system, while the consumer is responsible for applications and data. Understanding this model is crucial for effective cloud management and security. It ensures that both parties, the cloud provider and the consumer, are clear about their roles and can fulfill their respective responsibilities efficiently. Cloud models form the foundation of modern IT infrastructure, defining how businesses deploy and manage their computing resources. These models offer varying levels of control, flexibility, and cost-effectiveness, catering to diverse organizational needs. At the core, we have three primary cloud models: private, public, and hybrid. Each model presents unique characteristics and benefits, shaping the way organizations approach their cloud strategy. Private clouds, often viewed as an evolution of traditional data centers, provide a dedicated environment for a single entity. This model offers enhanced control and security, making it ideal for organizations with strict compliance requirements or sensitive data handling needs. In contrast, public clouds, managed by third-party providers, offer scalable resources accessible to anyone willing to purchase cloud services. This model democratizes access to advanced computing capabilities, allowing businesses of all sizes to leverage enterprise-grade infrastructure without significant upfront investments. Bridging these two approaches, hybrid clouds combine elements of both private and public models. This versatile setup allows organizations to maintain critical systems on premises while leveraging the scalability and cost-effectiveness of public cloud resources for less sensitive operations. As we delve deeper into each model, we'll explore their specific attributes, use cases, and the strategic considerations that guide businesses in choosing the right cloud deployment for their unique needs. Private clouds represent a significant evolution in enterprise IT infrastructure. This model offers a cloud environment dedicated exclusively to a single organization, providing a level of control and security that closely mirrors traditional on-premises data centers. One of the primary advantages of a private cloud is the enhanced control it provides. Organizations have complete authority over their infrastructure, allowing for precise customization of security protocols, compliance measures, and resource allocation. This level of control is particularly crucial for industries dealing with sensitive data or strict regulatory requirements. Flexibility in hosting options is another key feature of private clouds. While many organizations choose to host their private cloud on premises, leveraging existing data center investments, off-site hosting is also a viable option. Some businesses opt for dedicated facilities managed by third-party providers, combining the benefits of cloud computing with the security of a private environment. However, it's important to note that the advantages of private clouds come with increased responsibilities and costs. Significant upfront investment is often required for hardware, software, and skilled personnel. Additionally, ongoing maintenance and upgrades fall squarely on the organization's shoulders. Despite these challenges, private clouds offer unparalleled customization and security. They provide a robust solution for organizations that require strict data sovereignty, have unique compliance needs, or simply prefer to maintain direct control over their IT infrastructure. As we explore further, we'll see how private clouds fit into the broader spectrum of cloud models, and how organizations can leverage their strengths in a comprehensive cloud strategy. Public clouds represent a paradigm shift in how organizations access and utilize computing resources. Unlike private clouds, public clouds are built, controlled, and maintained by third-party service providers, offering their resources to the general public over the Internet. One of the defining characteristics of public clouds is their accessibility. Anyone with an Internet connection and a payment method can leverage the power of enterprise-grade infrastructure, democratizing access to advanced computing capabilities. This broad availability marks a key distinction from the exclusivity of private clouds. The economic model of public clouds is another significant advantage. Public clouds operate on a pay-as-you-go basis, allowing organizations to consume only the resources they need when they need them. This model eliminates the need for substantial upfront capital expenditures, making it particularly attractive for startups and small to medium-sized businesses. Scalability is a cornerstone of public cloud offerings. Organizations can rapidly scale their resources up or down in response to demand fluctuations, ensuring optimal performance during peak times and cost efficiency during lulls. This elasticity is particularly valuable for businesses with variable workloads or seasonal demand patterns. Public clouds also excel in the speed of deployment. New applications and services can be provisioned in minutes, dramatically reducing time to market for new products and features. This agility gives businesses a competitive edge in fast-moving markets. However, it's important to note that public clouds come with their own set of considerations. While providers implement robust security measures, organizations have less control over their data and may need to implement additional security protocols. Additionally, compliance requirements may limit the types of data or workloads that can be moved to a public cloud. As we continue our exploration of cloud models, we'll see how public clouds can be integrated with other models to create flexible, efficient IT environments tailored to an organization's specific needs. Hybrid clouds represent a strategic blend of private and public cloud environments, offering organizations the best of both worlds. This model creates an interconnected computing environment that leverages the strengths of both private and public clouds, providing unprecedented flexibility in managing IT resources. At its core, a hybrid cloud allows data and applications to move between private and public clouds. This interoperability enables organizations to optimize their infrastructure based on specific needs, compliance requirements, and cost considerations. For instance, sensitive operations can remain in the private cloud, while less critical workloads can take advantage of the scalability and cost-effectiveness of public clouds. One of the key benefits of hybrid clouds is the ability to implement cloud bursting. During periods of peak demand, applications running in a private cloud can burst into the public cloud, accessing additional computing resources as needed. This capability ensures optimal performance during high-traffic periods without the need for substantial investments in rarely used capacity. Hybrid clouds also offer a balanced approach to control and scalability. Organizations can maintain strict control over critical assets in their private cloud, while leveraging the virtually unlimited resources of public clouds for less sensitive operations or experimental projects. This flexibility allows businesses to tailor their cloud strategy to their specific risk tolerance and operational requirements. Furthermore, hybrid clouds provide an ideal platform for gradual cloud adoption. Organizations can migrate to the cloud at their own pace, moving select workloads to the public cloud while maintaining others on premises. This approach minimizes disruption and allows for a more measured evaluation of cloud benefits. However, implementing a hybrid cloud does come with its challenges. Ensuring seamless integration between private and public cloud environments requires careful planning and robust management tools. Security considerations also become more complex as data moves between different environments. In the realm of cloud computing, the consumption-based model stands as a cornerstone principle, revolutionizing how businesses approach IT infrastructure and resources. This model, fundamentally different from traditional IT procurement, aligns costs directly with usage, offering unprecedented flexibility and cost-effectiveness. At its core, the consumption-based model operates on a simple premise. You pay only for the resources you consume. This approach eliminates the need for significant upfront investments in hardware and infrastructure, traditionally associated with on-premises data centers. Instead, cloud providers offer a vast array of resources, from computing power to storage and networking capabilities, available on demand. This model falls under the category of operational expenditure, OPEX, contrasting sharply with the capital expenditure, CAPEX model of traditional IT infrastructure. In an OPEX model, expenses are incurred and paid for over time as part of operational costs, rather than as a large upfront investment. The flexibility inherent in this model is one of its most compelling attributes. Businesses can scale their resource usage up or down based on actual needs, ensuring optimal performance during peak times without the burden of excess capacity during lulls. This scalability is particularly valuable for businesses with fluctuating demands or those experiencing rapid growth. Moreover, the consumption-based model shifts the responsibility of infrastructure management to the cloud provider. This transfer of responsibility not only reduces the workload on internal IT teams, but also ensures that businesses always have access to the latest technology without the need for regular hardware upgrades. In essence, the consumption-based model in cloud computing offers a more agile, cost-effective, and scalable approach to IT resource management, aligning perfectly with the dynamic needs of modern businesses. In the context of IT infrastructure and cloud computing, understanding the distinction between capital expenditure, CapEx, and operational expenditure, OpEx, is crucial. These two financial models represent fundamentally different approaches to acquiring and managing IT resources. Capital expenditure, or CapEx, refers to the upfront investment in physical assets that a company expects to use for an extended period. In the IT world, this typically involves purchasing servers, networking equipment, and other hardware for on-premises data centers. CapEx also includes the costs associated with building or upgrading facilities to house this equipment. These investments are characterized by their significant upfront costs and the fact that they're depreciated over time. The CapEx model has been the traditional approach for many businesses. It offers complete control over the infrastructure and can be cost-effective for stable, predictable workloads. However, it also comes with challenges. The initial investment can be substantial, potentially straining cash flow. Moreover, accurately predicting future needs is difficult, often leading to either over-provisioning, wasting resources, or under-provisioning, limiting growth and performance. On the other hand, operational expenditure, or OpEx, represents ongoing, pay-as-you-go costs. In cloud computing, the OpEx model allows businesses to pay only for the resources they consume when they consume them. This model eliminates the need for significant upfront investments and shifts the responsibility of infrastructure maintenance to the service provider. The OpEx model, exemplified by cloud services, offers several advantages. It provides greater flexibility, allowing businesses to scale resources up or down based on actual needs. This agility is particularly valuable in dynamic business environments or for companies experiencing rapid growth. Additionally, OpEx costs are typically treated as business expenses in the same period they are incurred, which can have tax benefits compared to the depreciation of CapEx investments. The shift from CapEx to OpEx in IT spending represents a broader trend towards more flexible, scalable, and cost-effective solutions. While CapEx still has its place, particularly for businesses with stable, predictable IT needs, the OpEx model of cloud computing is increasingly becoming the preferred choice for organizations seeking agility and cost optimization in their IT infrastructure. Cloud computing has revolutionized the way businesses approach their IT infrastructure, and at the heart of this transformation lies the innovative cloud pricing models. These models represent a paradigm shift from traditional IT procurement, offering flexibility, scalability, and cost-effectiveness that were previously unattainable. The cornerstone of cloud pricing is the pay-as-you-go model. This approach allows businesses to pay only for the computing resources they actually use, much like how we pay for utilities such as electricity or water. This model eliminates the need for significant upfront capital expenditure on hardware and infrastructure, which has traditionally been a barrier to entry for many organizations. One of the primary benefits of this pricing model is the ability to closely align IT costs with actual business needs. In a traditional on-premises environment, companies often had to over-provision to handle peak loads, leading to wasted resources during periods of lower demand. With cloud computing, resources can be scaled up or down in real time, ensuring that you're only paying for what you need when you need it. This scalability is particularly valuable for businesses with fluctuating workloads or those experiencing rapid growth. During periods of high demand, additional resources can be instantly provisioned to maintain performance. Conversely, when demand decreases, resources can be scaled back, reducing costs. This elasticity ensures that businesses can respond quickly to changing market conditions without the constraints of physical infrastructure. Moreover, cloud pricing models shift the responsibility of infrastructure management to the cloud provider. This transfer of responsibility not only reduces the workload on internal IT teams, but also ensures that businesses always have access to the latest technology without the need for regular hardware upgrades. The cloud provider takes care of maintenance, updates, and security, allowing businesses to focus on their core competencies. Another significant advantage of cloud pricing models is the ability to treat IT expenses as operational costs rather than capital expenditures. This shift can have favorable implications for financial reporting and tax purposes, potentially improving a company's financial position. In essence, cloud pricing models offer a more agile, cost-effective, and scalable approach to IT resource management. They provide businesses with the flexibility to innovate rapidly, experiment with new ideas, and respond quickly to market changes, all while maintaining control over their IT spending. As organizations continue to embrace digital transformation, understanding and leveraging these pricing models will be crucial for maintaining competitiveness in an increasingly cloud-driven business landscape. Now, a Kaiwik knowledge check for you. What is cloud computing? Correct answer: delivery of computing services over the Internet. Explanation: cloud computing encompasses a wide range of services delivered over the Internet, including computing power, storage, databases, networking, software, analytics, and intelligence. While storage and website hosting are part of cloud services, the term cloud computing is broader and includes all types of computing services. Which cloud model uses some data centers focused on providing cloud services to anyone that wants them, and some data centers that are focused on a single customer? Correct answer: hybrid cloud. Explanation: a hybrid cloud combines public and private cloud environments. In this model, some data centers are used to provide public cloud services available to anyone, while others are dedicated to a single customer, private cloud. This approach allows organizations to leverage the benefits of both public and private clouds, balancing factors such as cost, scalability, and data privacy. According to the shared responsibility model, which cloud service type places the most responsibility on the customer? Correct answer: infrastructure as a service, IaaS. Explanation: in the shared responsibility model, the division of responsibilities between the cloud provider and the customer varies depending on the service type. Among the three main service types, IaaS, PaaS, and SaaS, IaaS places the most responsibility on the customer. In IaaS, the provider manages the physical infrastructure, virtualization, and basic networking. The customer is responsible for the operating system, middleware, runtime, data, and applications. In PaaS, the provider also manages the operating system and development tools, leaving the customer responsible for applications and data. In SaaS, the provider manages almost everything, with the customer primarily responsible for data and access management. Therefore, SaaS requires the most management from the customer, as they have control over and responsibility for more layers of the technology stack. Cloud computing has revolutionized the way businesses approach their IT infrastructure, offering numerous benefits that address key challenges in traditional on-premises environments. Two of the most significant advantages are high availability and scalability. High availability. High availability is a critical feature of cloud services that ensures applications and data are accessible whenever they're needed. In the context of cloud computing, high availability refers to the ability of systems to remain operational and accessible, even in the face of hardware failures, network issues, or other disruptions. Cloud providers achieve high availability through various strategies. Redundancy. Multiple copies of data and applications are maintained across different physical locations or data centers. If one instance fails, traffic is automatically redirected to a functioning instance. Load balancing. Incoming network traffic is distributed across multiple servers to prevent any single server from becoming overwhelmed. Failover systems. Backup systems are in place to take over if the primary system fails. Geographical distribution. Data and applications are spread across different geographical regions, minimizing the impact of local disasters or outages. Cloud providers often offer service-level agreements, SLAs, that guarantee a certain level of uptime, typically 99.9% or higher. This level of availability is difficult and expensive to achieve with on-premises infrastructure, especially for small to medium-sized businesses. Scalability. Scalability in cloud computing refers to the ability to increase or decrease IT resources as needed to meet changing demand. This flexibility is one of the most powerful features of cloud computing, allowing businesses to adapt quickly to changing requirements without significant upfront investment. There are two main types of scalability in cloud computing. Vertical scaling, scaling up-down. Vertical scaling involves increasing or decreasing the capabilities of existing resources. For example, you might add more CPU, RAM, or storage to a virtual machine to handle increased load. This type of scaling is useful when you need more power from a single resource. Horizontal scaling, scaling out in. Horizontal scaling involves adding or removing instances of resources. For example, you might add more virtual machines to a network to handle increased traffic. This type of scaling is particularly useful for distributed systems and can provide virtually unlimited scalability. The scalability of cloud services offers several benefits. Cost efficiency. You only pay for the resources you use. During periods of low demand, you can scale down to reduce costs. Improved performance. You can quickly scale up to meet sudden spikes in demand, ensuring your applications remain responsive. Future-proofing. As your business grows, you can easily scale your IT resources to match without needing to make large upfront investments. Many cloud providers offer auto-scaling features, which automatically adjust your resources based on predefined rules or real-time metrics. This ensures optimal performance and cost efficiency without constant manual intervention. In the realm of cloud computing, reliability and predictability are two crucial benefits that provide businesses with the confidence to develop and deploy solutions effectively. These features are integral to the Microsoft Azure well-architected framework, ensuring that cloud solutions are built on a solid foundation. Reliability. Reliability in cloud computing refers to a system's ability to recover from failures and continue functioning. It's a critical aspect of any IT infrastructure, but cloud computing takes it to a new level. Key aspects of cloud reliability include decentralized design. Cloud infrastructure is inherently decentralized, which contributes significantly to its reliability. Resources are distributed across multiple data centers and regions, reducing the risk of a single point of failure. Global scale. Cloud providers like Microsoft Azure have a global presence. This means that even if one region experiences issues, others can continue to operate, ensuring continuous service availability. Automatic failover. Many cloud services are designed to automatically switch to backup systems or alternate regions in case of failures, often without any intervention required from the user. Redundancy. Data and applications can be replicated across multiple locations, ensuring that there's always a backup available. Disaster recovery. Cloud platforms offer sophisticated disaster recovery solutions that can quickly restore operations in the event of a major disruption. This level of reliability is often difficult and expensive to achieve with on-premises infrastructure, especially for small to medium-sized businesses. Predictability. Predictability in the cloud context refers to the ability to foresee and manage both performance and costs effectively. This predictability is crucial for businesses to plan and operate efficiently. Performance predictability. Performance predictability ensures that applications and services will perform consistently under various conditions. Key features supporting this include auto-scaling. Cloud resources can automatically scale up or down based on demand, ensuring consistent performance even during traffic spikes. Load balancing. Traffic is distributed across multiple servers or regions to prevent any single point from becoming overwhelmed. High availability. Cloud architectures are designed to maintain performance even in the face of hardware failures or other issues. Performance monitoring. Advanced monitoring tools provide real-time insights into application performance, allowing for proactive management. Cost predictability. Cost predictability helps businesses forecast and manage their cloud spending effectively. This is supported by pay-as-you-go model. Businesses only pay for the resources they use, making costs directly tied to actual usage. Real-time tracking. Cloud platforms provide tools to monitor resource usage and costs in real time. Cost analysis tools. Advanced analytics help identify patterns and trends in resource usage, enabling more accurate future planning. Budgeting and alerting. Most cloud platforms allow setting budgets and alerts to help manage costs proactively. Total cost of ownership, TCO calculators. These tools help businesses estimate the full cost of moving to and operating in the cloud. By leveraging these features, businesses can build cloud solutions that are not only reliable, but also predictable in terms of both performance and cost. This predictability allows for more effective planning, budgeting, and resource allocation, ultimately leading to more efficient and successful cloud deployments. The combination of reliability and predictability in cloud computing provides a solid foundation for businesses to innovate and grow with confidence, knowing that their IT infrastructure can consistently meet their needs while remaining cost-effective. Manageability is a crucial aspect of cloud computing that offers significant benefits to organizations. It encompasses two main areas: Management of the cloud and management in the cloud. These two facets of cloud manageability provide organizations with powerful tools and capabilities to efficiently control and optimize their cloud resources and environments. Management of the cloud. Management of the cloud refers to the ability to manage and control cloud resources effectively. This aspect of manageability offers several key benefits. Automatic scaling. Cloud platforms can automatically adjust resource allocation based on demand. This ensures optimal performance during peak times and cost efficiency during periods of low demand. For example, a web application can automatically scale up its server resources during a traffic spike and scale down when traffic returns to normal levels. Template-based deployment. Cloud services often provide pre-configured templates for deploying resources. These templates encapsulate best practices and standard configurations, reducing the need for manual setup and minimizing the risk of configuration errors. This approach speeds up deployment processes and ensures consistency across multiple deployments. Automated health monitoring. Cloud platforms continuously monitor the health of deployed resources. If a resource fails or performs poorly, the system can automatically replace or repair it. This proactive approach minimizes downtime and maintains high availability without constant manual intervention. Real-time performance alerts. Cloud management tools can be configured to send alerts based on various performance metrics. This real-time monitoring allows IT teams to quickly identify and address issues before they impact users or business operations. Resource optimization. Many cloud platforms offer tools to analyze resource usage and provide recommendations for optimization. This can help organizations reduce costs by identifying underutilized resources or suggesting more cost-effective configurations. Management in the cloud. Management in the cloud refers to the various interfaces and tools provided to interact with and manage cloud environments. This flexibility in management approaches offers several benefits. Web portal interface. Cloud providers typically offer comprehensive web-based dashboards. These intuitive interfaces allow administrators to manage resources, monitor performance, and configure settings through a graphical user interface. This accessibility makes it easier for team members with varying levels of technical expertise to manage cloud resources effectively. Command Line Interface, CLI. For more advanced users or for automating repetitive tasks, cloud platforms provide command line tools. These CLIs allow for quick and efficient management of cloud resources through text-based commands, which can be easily scripted for automation. API-based management. Cloud providers offer extensive APIs, application programming interfaces, that allow for programmatic management of cloud resources. This enables organizations to integrate cloud management into their existing tools and workflows, or to build custom management solutions tailored to their specific needs. PowerShell scripting. Many cloud platforms, particularly Microsoft Azure, support PowerShell for cloud management. This powerful scripting language allows administrators to automate complex management tasks and integrate cloud management with other Windows-based systems. Third-party tool integration. The availability of APIs and standard management interfaces allows for integration with a wide range of third-party management tools. This enables organizations to use familiar tools or specialized solutions for multi-cloud management. Role-based access control, RBAC. Cloud platforms typically offer granular access control, allowing organizations to define specific roles and permissions for different team members. This ensures that users have access to the resources they need while maintaining security and compliance. Audit logging and reporting. Comprehensive logging and reporting features provide visibility into all management actions taken in the cloud environment. This is crucial for security, compliance, and troubleshooting purposes. The manageability benefits of cloud computing provide organizations with unprecedented control and flexibility in managing their IT resources. By leveraging these capabilities, businesses can optimize their operations, reduce manual overhead, and respond more quickly to changing needs. Whether through automated scaling and monitoring or through flexible management interfaces, cloud manageability empowers organizations to make the most of their cloud investments while maintaining efficiency and control. Let's review the correct answers and provide some additional context for each question. Which type of scaling involves adding or removing resources, such as virtual machines or containers, to meet demand? Correct answer: horizontal scaling. Explanation: horizontal scaling, also known as scaling out, involves adding more instances of resources to your system to handle increased load. This could mean adding more virtual machines, containers, or other compute resources to distribute the workload. In contrast, vertical scaling, or scaling up, involves increasing the capacity of existing resources, such as adding more CPU or RAM to a single server. Horizontal scaling is often preferred in cloud environments because it offers better flexibility and can provide virtually unlimited scalability. It also aligns well with the distributed nature of cloud computing and can improve fault tolerance by spreading the load across multiple instances. What is characterized as the ability of a system to recover from failures and continue to function? Correct answer: reliability. Explanation: reliability in cloud computing refers to a system's ability to continue operating correctly in the face of hardware or software failures. It's about ensuring that the system remains functional and accessible, even when components fail. Key aspects of reliability include fault tolerance, the ability to continue operating properly even when some components fail; redundancy, having backup components or systems that can take over if primary ones fail; automatic failover, the ability to switch to a redundant component automatically when a failure is detected; data backup and recovery, ensuring that data can be recovered in case of system failures. Predictability, while important, refers more to the consistent performance and cost of cloud services. Scalability, on the other hand, is about the ability to handle growing amounts of work by adding resources. Understanding these concepts is crucial for effectively leveraging cloud services and designing robust, high-performance cloud solutions. Reliability ensures that your systems remain available and functional, which is critical for maintaining business continuity and user satisfaction. Horizontal scaling allows you to efficiently manage resources in response to changing demands, which is a key advantage of cloud computing. Infrastructure as a service, commonly known as IaaS, represents the most flexible category of cloud services available today. This model provides customers with the highest level of control over their cloud resources, making it an attractive option for businesses with specific infrastructure needs. In the IaaS paradigm, the division of responsibilities between the cloud provider and the customer is clearly defined. The provider takes charge of maintaining the fundamental hardware components, ensuring robust network connectivity to the Internet, and implementing stringent physical security measures. This arrangement allows customers to focus on the aspects of infrastructure that directly impact their operations. As an IaaS customer, you assume responsibility for a wide range of tasks. These include the installation and configuration of operating systems, setting up and managing network configurations, and handling database and storage arrangements. Essentially, AS can be likened to renting state-of-the-art hardware housed in a cloud data center, with the freedom to utilize this hardware according to your specific requirements. The shared responsibility model is a crucial concept in cloud computing, and it applies across all cloud service types. However, in the case of IaaS, the model leans heavily towards customer responsibility. While the cloud provider ensures the upkeep of physical infrastructure and its internet accessibility, customers bear the responsibility for numerous critical aspects. These include software installation and configuration, regular patching and updates, and implementing robust security measures. IaaS proves particularly beneficial in certain scenarios. One common use case is the lift and shift migration strategy. This approach involves replicating your on-premises data center environment in the cloud, followed by a straightforward migration of your existing systems to the IaaS infrastructure. This method allows for a smoother transition to cloud computing without necessitating significant changes to your existing setup. Another scenario where IaaS shines is in the realm of testing and development. Many organizations have established specific configurations for their development and test environments. IaaS allows for the rapid replication of these environments, enabling teams to swiftly set up or tear down different setups as needed. This flexibility, combined with the complete control offered by IaaS, makes it an ideal choice for dynamic development and testing processes. Platform as a Service, or PaaS, occupies a middle ground in the spectrum of cloud service types. This model strikes a balance between the extensive control offered by Infrastructure as a Service, IaaS, and the fully managed environment of Software as a Service, SaaS. PaaS is designed to provide a robust platform for developers, allowing them to focus on application development without the complexities of managing the underlying infrastructure. In a PaaS model, the cloud provider assumes responsibility for a broader range of components compared to IaaS. This includes not only the physical hardware and network connectivity, but also the operating systems, middleware, and development tools. By handling these aspects, PaaS providers create a complete development and deployment environment in the cloud. For customers utilizing PaaS, the primary focus shifts to application development and data management. The platform provides all the necessary tools and services for building, testing, deploying, and scaling applications. This arrangement significantly reduces the time and resources typically required for configuring and managing development environments, allowing development teams to be more productive and agile. The shared responsibility model in PaaS is more evenly distributed between the provider and the customer compared to IaaS. While the provider manages the underlying infrastructure and development tools, customers are responsible for the applications they develop and the data they handle. This division of responsibilities allows organizations to leverage the expertise of cloud providers in infrastructure management while maintaining control over their core business applications. PaaS is particularly beneficial in several scenarios. For organizations engaged in rapid application development, PaaS provides a ready-to-use platform that can significantly speed up the development process. It's also ideal for situations where multiple developers are working on the same project, as it provides a shared development environment that can be accessed from anywhere. Another common use case for PaaS is when organizations want to create customized applications. PaaS platforms often come with pre-coded application components built into the platform, such as workflow, directory services, security features, and search functions. These components can dramatically reduce the amount of code developers need to write themselves. PaaS also shines in scenarios where developers want to automate testing and deployment services. Many PaaS offerings include tools for these processes, making it easier to implement continuous integration and continuous deployment (CI/CD) pipelines. By leveraging PaaS, organizations can focus on innovation and rapid application development without the overhead of managing complex infrastructure. This makes PaaS an attractive option for businesses looking to streamline their development processes and bring new applications to market more quickly. Software as a service, commonly referred to as SaaS, represents the most comprehensive and hands-off approach in the cloud service model spectrum. In this paradigm, customers are provided with a fully managed software solution, accessible via the Internet, typically through a web browser. SaaS eliminates the need for organizations to install and run applications on their own computers or infrastructure, simplifying maintenance and support. The defining characteristic of SaaS is that it places the least amount of responsibility on the customer compared to other cloud service models. In a SaaS arrangement, the cloud provider assumes management of virtually all aspects of the service. This includes the application software, runtime, middleware, operating systems, virtualization, servers, storage, and networking. The provider ensures that the software is automatically updated and patched, and that it remains available and secure. For SaaS customers, the primary responsibilities are limited to managing their data within the application and controlling user access. This significantly reduces the technical overhead for organizations, allowing them to focus on using the software to support their business processes rather than managing the technical aspects of software deployment and maintenance. The shared responsibility model in SaaS heavily favors the provider. While customers retain control over their data and user access, nearly all other aspects of the service fall under the provider's purview. This arrangement is particularly beneficial for organizations looking to minimize their IT management responsibilities and leverage sophisticated software solutions without the associated complexity of deployment and maintenance. SaaS finds its utility in numerous scenarios across various industries. One common application is in customer relationship management (CRM) systems. These complex software suites, crucial for managing customer. Let's take a moment to review our understanding of cloud service types. This knowledge check will help reinforce the key concepts we've covered regarding infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. The first question asks about which cloud service type is most suitable for a lift and shift migration from an on-premises data center to a cloud deployment. Think about the characteristics of each service type and which one would allow for the most straightforward transition of existing infrastructure. The second question focuses on a specific use case, a finance and expense tracking solution. Consider the nature of such a solution and which cloud service type would typically provide this kind of specialized, ready-to-use software. As you ponder these questions, reflect on the key differences between IaaS, PaaS, and SaaS. IaaS provides the most control and flexibility, but requires more management from the customer. PaaS offers a balance, managing the underlying infrastructure while giving developers control over applications. SaaS delivers fully managed applications, requiring minimal involvement from the customer in terms of management and maintenance. Take your time to think through each question carefully. Remember, understanding these distinctions is crucial for making informed decisions about cloud services in real-world scenarios. Correct answers. Which cloud service type is most suited to a lift and shift migration from an on-premises data center to a cloud deployment? Correct answer. A. Infrastructure as a service. IaaS. Explanation: IaaS is the most suitable for a lift and shift migration because it provides virtual machines and other infrastructure components that closely mimic on-premises infrastructure. This allows organizations to move their existing applications and workloads to the cloud with minimal changes. What type of cloud service type would a finance and expense tracking solution typically be in? Correct answer: C. Software as a Service, SaaS. Explanation: finance and expense tracking solutions are typically offered as SaaS. These are specialized, ready-to-use applications that are fully managed by the provider. Users can access the software via a web browser without needing to install or maintain any infrastructure or the application itself. Understanding these answers helps clarify the practical applications of different cloud service types. Yes offers the flexibility needed for migrations, while SaaS provides turnkey solutions for specific business needs, like finance and expense tracking.